Hello, ladies and gentlemen. We're going to talk about functions and how to tell if a relation is a function. If you're going to talk about functions, you first need to have some definitions under your belt. A function is a relation where each input has one output, which means every x value should have one y value that corresponds with it. And if there's ever an x value that repeats and has a different y value, then it's not a function. The other things we need to know is that a domain is going to be the inputs, which we'll usually refer to as x values, and a range is the outputs, which are y values. So we're going to go through sort of three different ways you can look at a function, and I'm going to show you how to look at that format and tell if something is a function. So the first thing is if you have a table of values. If I say list the domain, I'm just going to list all of the x's, and since I don't know if they're connected in between them, I'm going to just list them -2, -1, 0, 1, 2 in ascending order. That means from small to big. And when you're talking about sets, you want to use the curly braces to indicate that you're talking about a set. Neither of those are very good. Let's try again. Still not great, but okay. Range is the y's, 3, 4, 5, 6, 7. So when I list the range, I'll do this one in blue, 3, 4, 5, 6, 7, and I'll do my braces to indicate it's a set. Now, is it a function? Well, what you need to do is see if any x's repeat. Nope, there's no other -2s, there's no other -1s, there's no 0s, there's no 1s. If no x's repeat, then I'm going to say, yeah, this is a function. And I'm going to say no input has multiple outputs. You always want to very clearly explain why it is or is not a function. So yes, no input has multiple outputs. Basically no x repeat. If an x repeats, you got an issue. So in a table, we don't have any x repeats. Yep, it's a function. Let's try another one. Domain, -3. Now I'm not going to list repeats here. So if I've listed -3 once, I'm not going to list it again. So -3, 1, and again, I'm not going to list repeats. So I've listed -3, I've listed 1, and now I'm going to list 2. So my domain has really only 3 numbers in it. I'm not going to list repeats. Range, 1, 2, 3, 4. And again, since there's 2 3s, I just don't list the second one. 1, 2, 3, 4. You want to put it in ascending order. 2 is smaller than 4, so it should go first. 1, 2, 3, 4. Is it a function? Well, does an input have multiple outputs? -3 has 1 for an output, and -3 has 4 for an output. That means the first time I plugged in -3, I got 1, and the second time I plugged in -3, I got 4. That's not good. That means that this is not a function. The same thing happened with 1. 1 mapped to 2 and 1 mapped to 3. So this thing is super broken. It's not a function. 2 different ways. We're going to say no. You only need one counterexample, so I'm going to say an input has multiple outputs. And again, you want to be very specific now and say exactly which input. And the way I'll do that is I'll use this notation we're going to use for the mapping diagrams. I'm going to say -3, and I'm going to draw 2 arrows coming from -3. One of them is going to go to 1, and one of them is going to go to 4. -3 has 2 outputs, 1 and 4. That means that it is not a function. Last one, domain, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, that's my set. Range, 6, 6, 6. That's a lot of 6s. The range is 6. You do not list repeats, so there's only one number in the range. Now, this is tricky. No input can have multiple outputs. Are there any x's that repeat? No, 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 no. If x doesn't repeat, this is a function. No input has multiple outputs. Now you might be like, wait a minute, that 6 is in there 5 times. So, I didn't say anything about outputs repeating. If you were to graph this, it would be a horizontal line. That's a function. So it doesn't matter if the y's repeat, they can all be the exact same number. It is still a function. What you're looking for are the inputs. So summarize what you're looking for to determine if a table of values is a function. You are looking for x values that repeat and have a different, I'll stretch this out, different y value. You can write that however you want, but the gist of it is you are looking for x values that repeat. And if there are none, it's a function. If x's do repeat and have a different y value, then it's not a function because one input has multiple outputs. So that's one way to talk about functions if I give you a table. Another way I might talk about functions is if I give you a graph. So the domain is the x values. This thing I think is implied to go forever to the left and forever to the right. So if it goes forever to the left, then the smallest x value is negative infinity. And since we're talking about domain, we're going to say is less than x is less than forever to the right is positive infinity. Now, if you're in a later class, the notation we'll use, like in pre-calc, we'll say interval notation, negative infinity to infinity. But one thing that's important in either notation, if this was an equal to, that implies that you counted to infinity. No, you didn't. So you will always have a strictly less than, and you will always have a strictly less than in non-inclusive parentheses in interval notation. The range is the smallest y value to the biggest y value. So the smallest y value is -1. The biggest y value is +1. I'm looking at y values. You got to kind of switch your brain now. -1 to +1. So the way we'll write that normally in algebra 1, we'll say -1 is less than or equal to y is less than or equal to +1. In interval notation, that would be -1 to 1, and we would use brackets. The brackets indicate it is equal to or can be equal to. Is it a function? Well, I don't see any point on top of another point. I don't see any x's repeating, so I think I'm going to say yes, this is a function. No input has multiple outputs. You always want to say very clearly what's going on here. No input has multiple outputs, so yes, this is a function. Let's try another graph. Okay, domain, the furthest left you go to the furthest right. The furthest left you go, the x value is 3. So we would say 3 is less than x. It actually does equal to, so 3 is less than or equal to x. And then it goes forever to the right. So we're going to say is less than infinity. Or if you're in pre-calc, the way we would say that is 3 to infinity, interval notation. Range, smallest y value. Well, this thing goes up and down. It goes down forever and it goes up forever. So the smallest y value would be negative infinity. Oh, I lost something. Negative infinity. And then you would say is less than y is less than, if it goes up forever, positive infinity. In interval notation, negative infinity to infinity in parentheses. Is it a function? Wait a minute. I see 4 twice. 4 has an input, or as an input of 4 has an output of 0 and an output of -2. That's 2 different outputs. So is it a function? No, because there is an input that has multiple outputs. And you want to be more specific than that as well. We're going to say 4 has 2 outputs. It maps to both 0 and -2. And no input can have multiple outputs. If you ever find an example, then it is not a function. One way you can look at these problems when you're given a graph is called the vertical line test. So what I'm going to do is draw a vertical line. And I'm going to imagine that I'm taking this vertical line and I'm going back and forth. If I can ever draw a vertical line that hits the relation twice, then I have broken it and it's not a function. So I use this example, but it could be anywhere along the way. When I draw a vertical line, you see how I have x equals -4 in 2 different spots with 2 different y values. One is 0, one -2. If the vertical line ever hits the relation twice, it is not a function. So I could have been over here and be like, look, that vertical line crosses once, twice, which means it is not a function because that x value has 2 different y values. Let's try one more. Domain. So using the vertical line test, I'm going to be like, let's see, for the function test anyway, I don't see it it's hitting the relation once, it's hitting the relation once, come over here, once, it's not hitting it down below. So I think this is a function, but let's talk about domain and range. So domain, if this thing goes forever to the left, would be negative infinity is less than x, and then it goes to here, so we'll say is less than 0, the x value is 0, and, which we might use some different notations here. We might use set notation and say union 1 to 5. So we'll say 1 is less than x is less than or equal to 5. This is a piecewise function, so if you just list them out, that's okay for now. We'll talk about that notation more later. So we have negative infinity to 0, that's this piece, and then 1 to 5, that's this piece. But notice you have an open circle at 1, so you have a less than, and you have a closed circle at 5, so you have a less than or equal to. Now the range, I'm going to do the same thing. I'll list it two different ways. I'll say it goes forever down, and it cuts off here at -3, so this would be negative infinity is less than y is less than, the y value here is -3. Again, it's an open circle, so it's a less than. My other part of my range is right here. So the y value is, I'm from 4 to 8. So I would say 4 is less than or equal to y. It's a closed circle, so less than or equal to is less than +8. So there's two parts to these domain ranges. It's called a piecewise function. Is it a function? It sure is, because no input has multiple outputs. You're always pretty much going to say the same thing. Okay. No input has multiple outputs, so it's a function. It passes the vertical line test. And I'll now tell you I'll write out what the vertical line test is again. Draw vertical lines across the relation, and if any vertical line crosses the relation more than once, it is not a function, because that means you have multiple outputs for the same input. So you should never have a vertical line crossing more than once. That's graphs. Last one we got to do is, this is called a mapping diagram. So I'm first going to explain what a mapping diagram is. When we draw a mapping diagram, we draw sort of two ovals, and we'll put the domain in one oval, and we'll put the range in the other. And then you can see, if I say the domain is -1, 0, 1, 2, 3, then my x's should be -1, 0, 1, 2, 3. So you put the domain in the x's, and then you do the same thing with the y's. So 3, 5, 11, 21. 3, 5, even though there's two of them, I only put one in here, 11 and 21. You don't list repeats. So we have the domain in one, you have the range in the other. And then what you do to create your mapping diagram is, this is saying that -1 maps to 5. That means that there's an order pair. When I plugged in -1, I got 5. When I plugged in 0, I got 3. So 0, 3 is a point. When I plugged in 1, I got 5. 1, 5. 2, 11. 3, 21. So we might say, some vocabulary, -1 is in the domain and it maps to 5. So from -1, we draw an arrow to 5. And now it says, is this a function? And the answer is yes, this is a function, because you can see that no x has multiple outputs. -1 only goes to one spot. 0 only goes to one spot. 1 only goes to one spot. 2 only goes to one spot. 3 only goes to one spot. There are no repeat x's, so the answer is yes, this is a function because no input maps to more than one output. If I give you another one and I say, all right, what's the domain of this one? Well, the domain would be the x's. So the domain is 2, 3, and 4, and that's in a set. The range is 20, 30, and 40. 20, 30, and 40, that's also a set. And then, is it a function? Well, if I listed out the ordered pairs, I would have one ordered pair is 220, 220, and another ordered pair is 240. Wait a minute, 220 and 240. Right off the bat, I know this is not a function because 2 has two different outputs. So this is not a function, no. And I'll just say 2 has multiple outputs. What you're looking for is this 2 has more than one arrow coming out of it. It doesn't matter if they both point to 40, that's okay. No input can have two different outputs. So this is what breaks it right there. So I'll say 2 maps to 20 and 40, and that's why it's not a function. One more, domain. I'm going to do this in ascending order. So -1, 0, 3, 6, 14. That's my domain. My range would be -5, -2, 0, and 8. Is it a function? 6 only maps to one number. 3 only maps to one number. 0 maps to one number. -1 maps to one number, and 14 maps to one number. So yes, no input has multiple outputs. Okay, it doesn't matter if more than one, like they both pointed to -5. So what? It's the inputs that can't have more than one output. They can all have the same output. It's just no input can give you two different outputs. So if you're doing a mapping diagram, what you're really looking for is any value in the domain that has multiple arrows coming from it means there is a repeat x value. So it's not a function. I'll move that so you can see. Any value in the domain that has multiple arrows starting from it, like coming from 6, there's only one arrow. If I have more than one arrow, then I have a repeat x value. That's what we did up here. We had more than one arrow coming out of 2. That means it's not a function. So those are the three different, that's what's a functino? No, function. Okay. Those are the three different types of ways you might see a function, and you need to be able to tell me if something is a function using those different strategies. So you have a skills check that you should get done, and hopefully you get a 10 out of 10. Good luck.